I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is another very interesting video based on calculus. We'll look into the application of derivatives. From the equation, we'll try to find the local maximum and minimum points. We'll define the stationary and critical points, analyze gradient and the interval table. That will help us to sketch the curve for polynomials. We'll then connect with the graph of the functions and the derivatives and take up many test questions to practice. I hope that will bridge the gap and help you think critically in solving problems. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here. Let us enjoy the journey of learning with Akshit. Hi Akshit, how are you doing?
Hi, sir. I'm good. How are you?
Very good, very good. So now tell me in calculus, where are you and what are you doing at school?
Yes, sir. So right now we're on Unit 2 and we actually just finished the quotient rule after the product rule. So our test is placed for Wednesday.
Okay,
So that's where we are right now.
fine. So we are already ahead and your test is on Wednesday. We can move forward actually, right?
Yeah.
So I think we'll start with the next unit and
Okay.
work on analyzing the derivatives. Right?
Yeah.
What I mean to say is by analyzing the first derivative, we could actually find the maximum, minimum, and we can also sketch a graph of a function, especially polynomials will take up. And let's see how to
Yeah.
do all that. Is it okay?
Yes, sir.
So I'll share with you a lesson which I have specially prepared for
Yeah.
you. So in today's lesson, you can see my screen, right?
Yes, sir. I can see it.
Perfect. So in today's lesson, we'll talk about application of derivatives. You know what derivatives are. You've already
Yeah.
done. Let's now look into the application of derivatives. One of the important application of derivatives is find local maximum or minimum. Now, local maximum or minimum gives you optimization solutions, right? So
Yeah.
in what condition you can maximize the profit, for example. Where can you minimize the cost, for example? So this concept will help you in solving optimization questions later. Then we'll talk about stationary point and critical point. Now, these are two different terms. Critical point includes both. I mean, it is also a stationary point.
Yes, sir.
We'll look into what is the difference between the two. And then we'll take up how do we analyze the gradient with interval table. Very important technique to find the interval where the function is increasing, where
Yeah.
the gradient is increasing, or things like this. And then sketch the curve of polynomial. With the first derivative only, we will sketch some curves of the polynomials. Sketch graph from gradient, that is to say, if I give you the graph of a derivative function, then how do
Yeah.
you figure out the graph of the function itself, right? So sketch
Right.
graph from gradient. Gradient is the derivative. Is it okay?
The derivative. Yeah.
Examples to find local maximum and minimum and exam practice test. So that is what we are going to do this hour. Is it okay?
Yes, sir. Sounds
Ready
good.
for that?
Yeah.
Okay, great. So we'll begin with the first concept, and that is gradient. So what is the gradient? Tell me.
Sir, it's the slope of the derivative.
Slope gives you derivative slope of tangent line, and that is the gradient. So slope
Right.
represents the gradient of the function at any point on the function, correct? So
Yeah.
consider the function f of x equals to minus x squared plus 4. So what is the gradient for this?
Minus 2x, sir.
Minus 2x, right? I
Yeah.
also sketched the graph of this particular parabola. which is minus x squared plus 4, right?
Yeah.
And so we have a gradient, which is minus 2x. Now, gradient, let's try to analyze this gradient. So we are saying that the gradient f of x is equal to minus 2x, right?
Yeah.
So if x is 0, then what is the gradient?
0, sir.
0. So you can see if x is 0, the gradient is 0. That means this is the horizontal line, correct?
Right. Yeah.
So, and 0 gradient implies what? A turning point in this case, right? So,
In this case, yeah.
right, we can say turning point, right? In this case, it also employs a local maximum, right?
Yeah.
For a parabola, it is absolute maximum, but we'll write local maximum. In general,
Okay.
it
Yeah.
definitely is a maximum value. So, see, 0 gradient gave us quite a bit of information, that is a turning point, a maximum. But because the graph was there, easily I could say it is a maximum.
Yeah.
Let's say we have a complicated function and we need to figure out at this point, where you have derivative as 0 is also called stationary point or a critical number.
Okay. So they're both the same thing, sir?
Now, critical number also includes the point where the derivative does not exist. So that is the difference.
Oh, okay.
So, yeah, so let's get into the definition. Can you please read this definition of critical number?
Yes, sir. Critical points on the graph of function are the points where the derivative is 0 or it does not exist. At these critical points, we may have local maximum or local minimum value.
We may have, not necessary
Yeah.
we will have, correct? Can you give me an
Correct.
example where the derivative could be 0, but it is neither a maximum nor a minimum?
Yes, sir. For example, if we take the absolute value function at x equals 0, the derivative doesn't exist, but is that still considered a local maximum or minimum?
It is a minimum, yes, because it does not exist. It is still a critical number, correct? So you
Yeah.
can analyze and figure out that this is a minimum, right?
Right.
But can you give me an example where the derivative is 0, but it is not a local minimum or maximum?
Okay, so if the derivative is 0, then that means the slope of the tangent would be horizontal, right, sir?
Yes, that is correct. But still,
So can
it is not a turning point. Yes, tell me.
okay, so if still it's not a turning point,
Yes.
then for example, a cubic function, right, sir?
Very good. Very good. Very good. So
Yeah.
cubic function. Let's see. If I find the derivative of this function, it is what?
3x squared.
3x squared. Do you see that?
Yeah.
So if that is the derivative, 3x squared, then in that case, we will see how do we figure out that we do have a maximum or a minimum, right? You know the graph
Yeah.
of x cubed, right? Graph of x
Yes, sir.
cubed is kind of like this, right? Do you see that?
Yeah.
And clearly, we do have at 0 a horizontal line. This is what we have, right?
Yeah.
Correct? So it is,
Correct.
but it is not a turning point, right?
Right. So you said it was called the point of inflection, right?
Yes, I
For
told you
the
earlier, this is called point of inflection.
yeah.
Now the idea is, how do we test algebraically so that we can figure out that this is not a turning point, this is not a local maximum or minimum, whereas
Yeah.
the previous one is a local maximum, right? This is what we are going to
Yeah.
learn. Is it okay? So look
Yes,
here.
sir.
In the first function which we are looking at, we know the derivative is minus 2x.
Yeah.
And the critical number is at x equals to 0. Because at x equals to 0, our derivative is 0, correct?
Correct.
This particular 0, which is a critical number, divides the plane in two parts. On the left side,
Oh,
the right
okay.
side. We can test both these parts, right? So I
Yeah.
can have a value minus 0.1 on the left side plus
Yeah.
0.1 on the right side. And when I substitute this value in my derivative, f prime x, then if I substitute minus, minus, minus becomes plus, and you get a positive
Positive. Yeah.
increasing. Positive means increasing. So the graph, as you
Right.
can see also, is increasing in this particular interval, right?
Yes, sir.
On the right hand side, it becomes decreasing. And since the derivative changes from increasing to decreasing, we land up at maximum for the critical number, correct?
Yeah. Exactly.
That is how we figure out that this should be a maximum, correct? Now let's try to
Correct.
analyze f prime x equals to 3x squared. So if I have this derivative, f prime x, and here
Yeah.
also, we do have a critical number, which is at x equals to 0, right?
Yeah.
If I take a negative value and a positive value, for example, right?
Yeah.
So the function here is 3x squared, right? 3x.
Yeah.
If it is negative or positive, x squared will make it positive, right?
Always increasing. Yeah.
So basically, it is like increasing and then again increasing. You get the idea.
Yeah.
So it is not increasing, decreasing, or decreasing, increasing. That means
Yeah.
it is not a turning point. You get the
Right.
idea? So
Yes,
that
sir.
is using a table, we can analyze the first derivative and figure out in which interval is the function increasing or decreasing.
Yeah.
So the interval where it is increasing is from minus infinity to 0, and where it is decreasing is from 0 to infinity. Is that clear to you?
Infinity. Yes, sir. Clear.
All this information you can get from the first derivative of the function. Is this point clear to you?
Yes, sir. Clear.
So can you please answer this question? Question 1.
Yes, sir. Are all critical points stationary points?
Okay.
Sir,
So stationary points are the turning points. Is that okay?
yeah.
Where you turn, you kind of stop, right? So it's a stationary
Right.
point.
Yeah.
So as you can see, you have this point of inflection, right? It is not a stationary.
Yeah.
So that is
Right.
your perfect. You already answered this question. So next example here is consider the function x squared minus 4. So this time the derivative is positive 2x, right?
Positive.
Now
Right.
again you can analyze, and this is like a practice question for you. Once you analyze, you again figure out that at 0 we have a horizontal tangent, because if I substitute 0 for x, I get the first derivative as 0. So the critical number is x equals to 0, right?
Yes, sir.
So that becomes a critical number. Now if I take a negative value on the left side of 0 and any positive value on the right side of the 0, I see that the derivative, we have to analyze the derivative, right, is
Yeah.
decreasing on the left side, increasing on the right side. Net result is a local minimum. Is that clear to you?
Yes, sir. So this would also be a critical point, right?
It is a critical point. So critical
Yeah.
point means both stationary. So let's understand. So when we talk about critical number, basically you say,
Yeah.
that means that the derivative is equal to 0 or the derivative does not exist, right?
Yeah.
Does not exist in the case like this, cusp or a corner. And you see,
Right.
at every cusp or a corner, you either have a local maximum or a local minimum,
Local
right?
minimum.
And
Yeah.
that does not exist. You get the idea. But
Yes, sir.
may not exist even for a vertical asymptote. There you have none of these. So this is
Yeah.
a condition which could be true. We have to prove it to be true using this table. You get the idea.
Yeah.
And continuity, of course. So if it is not defined, for example, 1 over x is not defined at x equals to 0, you cannot have a local maximum minimum at that point.
Yeah.
Correct?
Correct.
Please read question number 2a and b.
Yes, sir. Question 2a. Find the critical points on the graph of f of x equals x cubed plus 1. Question 2b. Explain why the critical point found above is not a stationary point.
We answered this question. Can you answer the question once again?
Yes, sir. So the critical point we said would be the point of inflection, right?
Yes.
And then it's not a stationary point because when we do the interval table, right, we can see that the function is still increasing. So
Amazing. Good job. So this is another cubic function before you. So I'm trying to show you the question alone. Can you please read
yeah.
the
Yes, sir. Example 1. Analyze stationary point for local extrema.
Correct.
Find the stationary points on the graph of f of x equals x cubed plus 6x squared minus 32, and then sketch the curve of f of x.
Correct. So can you please write down the function and sketch
Yeah.
the function, find the derivative? Right.
Yes, sir. So the derivative would be 3x squared plus 12x.
Yes.
Yeah. And then it's a parabola, right? So
yeah, we factored it, right?
Yeah, we factored it. And then we can find that the stationary point, we can plug in x is 0, right? and x is negative 4.
Yeah, x is negative 4. Correct? So there
Right.
are two critical numbers or could be stationary points. So in this time, in the table, we'll have these two. Do you see that? At x
Yes,
equals to
sir.
minus 4 and x equals to 0, we have two stationary points. Now, if we
Yeah.
have two critical numbers, in that case, it divides the whole plane in three portions. Do you see that?
3 portions. Correct.
1, 2, and 3. So take a test point in all the three, one by one. So on the left
Yeah.
side of minus 4, I have taken my stationary point, critical test point as minus 5.
-5.
Between minus 4 and 0, I've taken minus 1, and beyond 0, 1.
Yeah.
Now, my derivative was 3x times x plus 4, written in factored form. So 3x and x plus 4 are the two factors. If I substitute minus 5 in 3x, I get a negative value. Minus 1 gives me negative, plus 1 will give me positive value.
Positive.
We don't
Yeah.
really want the value. We only are interested in the sign of the number, right?
Right.
For x plus 4, it would be negative for minus 5, but positive for minus 1 and 1. Now,
Yeah.
when you multiply two negatives, you get a positive. You have to multiply since the derivative is product of two, right?
Yeah.
3x and x plus 4. So it is increasing. But when you multiply with negative and positive, you get negative. So in that interval between minus 4 and 0, the function is decreasing.
Decreasing.
Thereafter, again, it is positive, it is increasing. So clearly, we have a local maximum here, right?
Yes, sir.
And a local minimum at 0. Do you see that? So by
Yes, sir.
analyzing the first derivative, we can very clearly find local maximum and minimum, correct?
Yeah.
Perfect. So that is how we'll find local maximum minimum. These are the calculations which will help you find the value of maximum, right? You know that the local maximum is at minus 4. Substitute minus 4 and find the value, right?
Yeah.
In the function, right? In the function, correct?
Right, sir.
And then similarly, you can substitute the other value 0 in the function and find that will be minus 32. So you have both the values, and these values will help you sketch the graph. Is it okay?
Yes, sir. Clear.
Now, the other part way is to, because the part of the question is to sketch the graph also, right? Now we know
Yeah.
local maximum and minimum. These are the 2 points which we figured out, correct?
Correct.
So let's go step by. So we know that if I substitute minus 4 in this particular expression, what do I get? The calculations show that at minus 4, the value is 0.
0.
So at minus 4, which is the maximum, the value is 0. That means on this side, it is 0, right? And when
Yeah.
I substitute 0, I get minus 32. I should have written minus 32. It's a typing error. Minus 32. So local minimum is at 0 minus 30. So I got these 2 points, right?
Right.
So I have these 2 points. One point here is at minus 4, I have 0. And the other
Yeah.
point is at 0, I have minus 32. Right?
Correct.
Now, you could, we know we have one of the x-intercepts at minus 4, correct?
Yeah.
Since you know that x-intercept, you can find the other x-intercept also, correct? How will you do?
Yeah.
You remember the long division process?
Yes, sir. You can use long division
So you can
or
use long
synthetic
division,
division.
which we did with the help of, what do you call this method?
Sorry, synthetic division.
Synthetic division. And so you get your parabola equation here, and clearly we could write our function as x plus 4 times x squared plus 2x minus 8, right? From these three values.
Yeah.
You can factor x squared plus 2x minus 8 using product and sum. You get two other factors, correct?
Yeah. Yes, sir.
And you figure out that actually speaking, at you see there is a turning point here, and this is also at origin, right? X plus 4 whole square. Do you see
Yeah.
that? And x
Yeah.
minus 2, a linear 0 on the other side. Is that clear to you?
Yes, sir.
So we have a linear 0 at minus 2. So that is how you'll actually graph your function. So is this process of graphing a function clear to you?
Yes, sir. Clear.
Can you summarize this? How do we graph a function using first derivative? For example, you've taken this cubic function.
Yeah.
Yeah, here is the graph of this function. Yes, explain me. How did you graph this function? Given f of x is x cubed plus 6x squared minus 32.
Yes, sir. So initially, to begin the process, we find the derivative, which would be 3x squared plus 12x in this case. And to make it simpler for ourselves, we can factor that because we see 3x as a common factor. And based on that, we get the zeros, or in other words, the stationary points for the function.
Yes.
So then after plotting those stationary points, we can plug them back into the original f of x to find their corresponding y values. And then since we know that they're both factors, we can then use synthetic division to find the rest of the factors so that we know how the graph behaves at each zero.
Yeah. So you were in a position to even find the other x-intercept using factoring, which we learned, factor theorem. Correct?
Yeah.
Very good job. Okay. So now here's another question for you. Can you please read the question? Example 2a.
Yes, sir. Example 2a. Understand graph of derivative. Given the graph of f prime of x, for what values of x does f of x have a local maximum and a local minimum?
Tell me. So
Yes,
we are
sir.
given a
So,
function and the graph is of not function but f prime x. Do you see that?
yeah.
Now tell me, for what values of x does f of x has local maximum? Tell me. This is the derivative function. Tell me. Local
So,
maximum is
yes, sir. So if this is the derivative, then the parent function should be uh, quartic, right? Because this is
quartic.
degree 3.
Yes.
Yeah. So for what values of x does f of x have a local maximum, right?
Yeah.
So, sir, it would have a local maximum at the top of the cubic functions, right?
Not no. Local maximum is a point where the derivative is changing from positive to negative. You
Or
get
to
it?
negative. Yeah.
So where does it change from positive to negative? At this point, you see, this is a graph of derivative. So derivative is positive from 0 to 1, correct? At,
Okay. Yeah.
at 1, it changes from positive to negative, right? It is going down, positive to negative.
Yes, sir.
Therefore, at this particular point, we are going to have a local maximum, right?
Yes, sir.
You get it's very tricky question because
Yeah.
otherwise, so if you know that you have to understand it now, right? So local maximum at x equals to 1, right? Where is
Yeah.
local minimum now? Tell me.
Wait, sir. Quick question. So, but for the local maximum at x equals to 1, we said that it's because it's changing from negative to positive, right?
Positive to negative.
So can we
Local,
see how?
local maximum. Derivative is positive here. This is the derivative. You see, and this is negative. Below x-axis.
Okay. Yeah.
It doesn't look like that, but it's
Yeah.
positive here also, right? This is all positive portion, correct?
Yeah. I couldn't tell. Yeah.
Now it is negative. After this point, it changes from positive to negative, right?
Yes. I thought because at the top of when it turns, that's when it would be changing from positive to negative.
No.
Yeah.
So when the first derivative is 0, first thing is, when the first derivative is 0, which is at these 3 points, right? We
Yeah.
could have local maximum minimum. These are 3 critical numbers. Do you understand?
Yes, sir.
Out of these, some will be maximum, some will be local minimum, some will be neither. Right?
Yeah.
So to figure it out, we are seeing how does the derivative change. So from here, this is negative and goes to positive, means this is like this. Negative going to positive means local minimum. Do you see that?
Yeah. Local minimum. Correct.
So minimum at 0.
Yeah.
Similarly, this is also negative and going to positive. So this is also minimum, correct? So at 0 and
Yeah.
2, we have local minimum. Do you understand?
Okay. Yeah. Got it.
So that is how you're going to answer this question. Is this
Yes,
concept?
sir. So you have to basically analyze the y values, the sign of the y values, right?
Yes, derivative sign.
Yeah. The derivative. Got it.
This is not a function given to you, as you say,
Yeah.
right? Now, so these two things are very correct. Now, 2b is sketch the possible graph of f of x. You said f
Yeah.
of x is quartic. So in quartic, f of x, at least local maximum minimums, right?
Right.
You don't have the value in mind, but you have approximate idea that this is a
Yeah.
quartic function where initially it is decreasing. Do you see initially it is negative?
Yeah.
So it means it is going
Initially.
like this and then going like this and then going like this. You get the idea?
Yes, sir.
So initially it is decreasing because it is negative. After it becomes positive, right? So you have local minimum right there, right? So this is at 0,
Yeah.
local minimum, right? And like
And
minimum,
then a 2.
and that is the maximum at 1, right?
Yeah.
Mean x equals to this is a maximum. And then at 2, as you say, is again a minimum, right?
Right.
Very clear? These 3
Yes,
points.
sir.
Now, one thing is very clear, these 3 points. Now, the maximum rate of change is at this point, right? Maximum rate of change corresponds to point of inflection of concavity.
Oh, okay.
So at this point, which is between 0 and 1, which is 0.5, as you can
Yeah.
notice, let me just highlight this point. Concavity changes. Do you see that?
Yes, sir.
Concave up and then concave down.
Oh, okay.
This is another point where the concavity changes. You see,
Right.
down, then up. So we
Yeah.
have actually, without values, sketched
Yeah.
how the graph of the function is going to look like. You get the idea.
Sir, so the rate of change would be the greatest to the left and the right of the maximum, right? On the
Yes.
original f of x? Okay.
Yes. This is giving you value of rate of change, right? So rate of
Right.
change from the graph is shown to you maximum at this point and minimum at that point. Correct?
Correct. Yeah.
Turning points. So they
Yeah.
corresponds to point of inflection. I
Yeah.
like you to read all this.
Yes, sir. The graph of f prime of x indicates critical points at x equals 0, 1, and 2. When x equals 0, f prime of x changes from negative to positive, resulting in a local minimum. When x equals to 1, f prime of x changes from positive to negative, resulting in a local maximum. And when x equals to 2, f prime of x also changes from negative to positive, resulting in a local minimum.
Correct.
Yeah.
Next part. Graph.
So when
Okay, so we have identified local maximum minimum, right? So that
yeah,
means we identify this point, that point, and this point on quartic function. Do you see that?
yeah.
Next, please read.
So when f prime of x is greater than 0, it indicates that the function f of x is increasing. And when f prime of x is less than 0, it indicates that the function f of x is decreasing. And when f prime of x equals to 0, it indicates that f of x is a turning point.
Right.
The
Those are
maximum,
continue.
yeah, the maximum and minimum on the graph of indicates point of inflection on the graph of f of x. We will discuss this more in details later. The graph of f of x will be a quartic function since the derivative is cubic.
Right. Is this all clear to you?
Yes, sir. Clear.
Extremely important question, right? So
Yeah.
understanding early on all this is very, very important, right?
Yeah.
Perfect. So let's move on to the next example, which is very difficult. I like you to read the question, right?
Yeah. Example 3. Identify local maximum and minimum points of a function. Find the values of x for f of x equals x squared, cube root of 6x squared minus 7 will have a local maximum or minimum.
Yeah. Find the values of x for f of this function, where this function will have local maximum minimum. Is it okay?
Yes, sir.
Find the values of x for this function
Yeah.
where f of x will have local maximum minimum. Right? So you have to find local maximum minimum for this function. Now, can you do this derivative? We have f of x as x squared, and the other
Yeah.
product is cube root of 6x squared minus 7. Try it out, and then we'll discuss.
Okay, sir.
The part here is how do you factor that cube root factor? Very difficult. So I
Yeah.
like to try it out first, okay, on your own.
Okay, sir. Sir, I found the derivative.
Very good. So could you factor the derivative? So you use the product rule to find the derivative, and the second part is also chain rule. You understand? So
Yes,
can
sir. And the chain.
what is the derivative of this function?
Yes, sir. I got 2x, and sorry, this is the numerator. 2x, 4x squared minus 7 over 6x squared minus 7 to the power of 2/3.
Correct. Very good. So you got the end result, which is right there.
Yeah.
But, so that is the derivative. Now, can you tell me how will you analyze this derivative to find local maximum minimum? Tell me that.
Yes, sir. So this derivative would represent the rate of change for the function, right?
Yes.
So to find the critical points, we can find factors, right?
You have already factored 2x times 4x square minus 7 divided by 6x square minus 7 to the power of 2 over 3, correct?
Yeah.
Now tell me, where is this derivative 0? What are the critical numbers? X equals to what is zeros? 0?
Yeah, x equals to 0 and the square root of 7 over 4.
So plus minus
Plus minus.
7 over 2, right? Square root
Oh,
4.
7 over 2. Sorry. Yeah.
And even denominator could be 0, right?
Yeah.
So what else?
Sir, it would be 7 over 6, right? Plus minus square root.
You are right. So these are all your critical numbers. You get the idea?
Yeah.
These are all your critical numbers. And what you're going to do, this is what you have to do as a homework.
Yeah.
All these critical numbers, you have to arrange them in a table, right? So you
Right.
have plus and minus, let's say 0, right?
Yeah.
This, and then we have plus and minus 7 by 2. 7 by 2 was square root of 7 by 4, right? And plus
Yeah.
and then you have the other. So all these points which you have on the number line, you have to take test points in between. Do you see that? And figure
Yeah.
out whether the derivative is increasing or decreasing. How is it changing?
Right.
Once you work out that, you will know local maximum minimum.
Yeah.
Correct? So that is your homework exercise. Is it okay?
Yes, sir. Yeah.
So analyze. It's a very difficult test question. Next question. Now we have 3 more questions for you to do. We can solve these questions one by one.
Yeah.
Question number 1. Can you please read and answer?
Yes, sir. Find critical points on the graph of f of x equals 3x to the power of 5 minus 5x cubed.
Yeah.
Find local maximum and minimum for the function f of x. Which critical points are not turning points on the graph?
Answer.
So you can factor x cubed, and you'd be left with 3x squared minus 5.
Okay, first we find derivative.
Yeah, first we find derivative, so it'd be 15x4 minus 15x squared.
Factor.
Yeah. So your critical points would be 0.
Yes.
And plus minus 1.
Correct. So now we have our critical points. Let me just move up. So let me draw a line here, right? So I'll use a different method which is faster. So we have a 0 at 0 and then at plus and minus 1, correct?
Yeah.
Oh, this is plus 1, correct. Now, so those are our zeros for the derivative. So derivative is f prime x. It has 3 factors. One of them is 15x squared. We know 15 is a constant. So, but still it's a good idea to write all the factors, right? One of them is x plus 1, and then we have x minus 1, right? These are the 3 factors. Now, in these intervals, let's take some test points, right? So, test point could be minus 2. So, these are my test points, correct?
Yes.
Here, the test point could be minus half or 0.5. Here, I could take half, and here I could take. Now, if I substitute these values in this interval, so let me just draw these lines so that it's clear for us in which intervals we are getting positive result, where are we getting negative result. Is it okay?
Yes, sir.
Now, tell me, if the value is minus 2, then x square will always be positive. So clearly for us, we know this value is always positive, right?
Yeah.
Because it is x squared, nothing to worry about. X plus 1. If I have minus 2, it is going to be negative, right? Minus half, thereafter it is going to be positive. x minus 1. Minus 2 is negative, minus half is negative, half is also negative, plus 2 is positive. So we now know what is the sign for the derivative itself. So when you multiply plus minus minus, what do you get? You get plus, right?
Plus. Yeah.
Here you get minus. Here you get again a minus, right?
And plus.
So that clearly means that your function is increasing, decreasing, again decreasing, and increasing.
Yeah.
So we do have one maximum, and this maximum happens to be at x minus 1, correct?
Correct.
So x equals to minus 1, we have a local maximum. And here, again, at x equals to plus 1, we have a local minimum, right?
Right.
To find the value, you can substitute in the function and find what is the local maximum minimum value at plus and minus 1, correct?
Correct.
And at x equals to 0, it is not a stationary point, right? Because
yeah,
it's not changing, decreasing, decreasing.
decreasing.
Does it make sense?
Yes, sir.
So that is the way to do it. So you can actually see it properly so that you understand completely how do we solve such a test question, okay?
Yeah.
Is it clear? Can I erase it?
Yes, sir. Clear.
Very good. So let's move on and check question number 2. Can you please read question number 2?
Yeah. Given f prime of x equals x plus 3 and x minus 3 cubed, sketch the graph of f prime of x, identify local maximum and minimum on the graph of f of x, and sketch the graph of f of x.
Correct. Do it. Do it. So let's try
Yes,
it.
sir.
And then we'll compare the answers. Is it okay?
Yeah. Sir? Sir?
Yes.
Sir, I got a local minimum at -3.
At -3.
Yeah.
So this is the derivative, correct? Let's be very.
Yeah.
We're talking about the derivative of the function, correct?
Correct.
And as you can see, this is cubic. Therefore, this is like a cubic function, right? And this is linear, right? The way it is changing.
Right.
Now, you got what local maximum where?
Local minimum, sir, at -3.
Local minimum. Explain why.
Because the rate of change goes from positive to negative at -3, sir.
Okay. So this portion is positive. Let's be very clear about it. This portion is positive. This portion is negative. When the
Right.
derivative is positive, that means function is increasing. And when derivative is negative, function is decreasing. And therefore, this should be local maximum, not.
Oh, local maximum.
You get the idea?
Yes,
so,
sir.
Don't do this mistake in the test. This is a common mistake. You get the idea?
Yes, sir.
Now, next point. It is negative, right? Negative means don't see the curve. See negative and positive means increasing. This is function. Do you understand?
Yeah.
That is derivative.
Right.
And so we have local minimum here. Get the idea?
Yes,
so
sir.
You can always substitute the values, get the local maximum minimum point, just plug in and get the answers. So is that clear?
Yes, sir. I was just confusing myself with the orange graph.
Yes. Okay, so we're done. Question number 2. Good job. Question number 3 for you now. Can you please read question number 3?
Yeah. Consider the function f of x equals 3x to the 4 plus ax cubed plus bx squared plus cx plus d. Find the constants a, b, c, and d if the graph has critical points at -2, -73, and 0, -9.
Correct.
Yes, sir. Find the third point where the graph will have a horizontal tangent and
Yes.
analyze the gradient to find the local maximum and local minimum for the given function.
Excellent question. It has been seen in previous test papers. So tell me your strategy. How will you answer this question?
Yes, sir. So if we're given the function as 3x4 plus ax cubed plus bx squared plus cx plus d, and the graph has critical points there, right? So then they're referring to the derivative, right? So we should actually find the derivative first.
So first, if we have a function here. Now,
Yeah.
how many equations do you need to solve this question? Tell me that.
Pardon, sir?
How many equations should I have to find the value A, B, C, D?
4 equations, sir, because they're 4 unknowns.
4 equations. This is first thing we have to start with, right? So when you think like
Yeah.
this, you have to think like, right? So what are we looking for? We are looking for 4 equations. Tell
Right.
me, how will you get 4 equations to solve?
Sir, we can easily get 2 equations from the given 2 points. The derivative makes our third equation.
So f of -2, right?
Yeah, f of
Is
minus
given
2.
to us as -7. As a critical point, -2, -73 means at f of -2, the point is -73, correct?
Correct.
Second equation, at 0, the value is
Minus.
-9, right?
Yeah.
You know, d is -9, straight, correct?
Yeah.
So we have 2 equations. Of course, you'll plug them in and you'll get 2 equations. And the other 2
Right.
are derivative, right?
Correct.
So let's write down the derivative now. So derivative will be
12x cubed
uh,
plus 3ax squared plus 2bx plus c.
correct. Now from here in the derivative also we know there are 2 derivatives at -2 is 0, right?
Yeah.
And at 0 also is 0, correct? So you
Correct.
have 4 equations. So since you have 4 equations, you can easily solve this question and get the values of A, B, C, D.
Sir, quick confirmation. So how did we find out that f at -2 is equal to 0?
Because this is a critical number, right?
Right. Okay. Critical points.
So because it is a polynomial, since it is a
Yeah.
polynomial, the critical number will also be a stationary point. Because polynomials do not have it is a smooth curve, right? They do not have
Yeah.
a corner.
Yeah.
So the derivative cannot be undefined. So it
Right.
can be only 0. So the critical numbers are also stationary points. Now we
Okay.
have this, right? I should say you need to now figure this out, but I'll leave it for you. So one
Yeah.
thing here we have 4 equations. Part B. Can you please read part B now?
Find the third point where the graph would have a horizontal tangent.
So we're given 2 points already. But once you
Yeah.
have the value of A, B, C, D, you know the function.
Yeah. Yeah.
Find the third point. Part C.
Yes, sir. Analyze the gradient to find local maximum and local minimum for the given function.
Very good. So that is what you have to do, and this is also your homework. Is that clear?
Yeah.
So with that, you'll get very good practice on this new unit, which we started today. And
Yeah.
I hope you have understood all the concepts, correct?
Yes, sir.
I'd like you to summarize today's learning.
Yes, sir. So today's class I found very similar to a lot of advanced functions concepts. I saw how they were directly linked with calculus. And I really liked the constant question, for example, because it really tied all the concepts together, where we touched upon, for example, all the principles of the derivative and how it can relate to finding the function. So how we can work backwards from the derivative to the actual function. So I think if I do get a question like that in the test, I'll be able to answer it with more practice.
Sure. Great. So we'll end the class here, Rakshit. All the best. Try these questions. Also try some more videos, some more of my videos from YouTube channel. You should
Yeah.
be set for this unit. And we'll take from here next time. Okay.
Yes, sir. Okay.
Okay then. Bye.
Bye, sir.